Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother Joel. We're here to hopefully show you how to approach SAT math questions. But last week came up with the brilliant insight of not only approach how to do the question the day of the test, but how to approach studying for the SAT. They're different things. We agree that when you study, you want to try to understand the problem completely from all facets. That allows you, perhaps on the day of the test, to do the problem a little faster than you would have done and more efficiently than you would on a chapter test in school. So today we're going to do Khan Academy, and we're going to go through some unit questions. This would be question 11 out of 20, and we'll decide later to see whether we're going to blast through these five, or whether we're going to do one at a time over the next few months, not years, God forbid. Let's go. Okay, here we have a unit question for practice. The strength of a magnetic field is measured in Tesla. 1 Tesla is equal to 1 Weber per square meter as follows. Wait, that's nice. Okay. Someone is building a circuit for her physics class. Point P on one of her wires. Okay, here's point P. On one of her wires is a magnetic field strength of Webers per square megameter. Oh, and they tell you megameter is 1 million meters. What is the magnetic strength in Teslas? Well, that's unit conversion. Please stop it, pause it, and then come back. They want to know so obviously this is unit conversion, right? What is the magnetic strength in Teslas? 1 Tesla is 1 Weber meter per square meter. Now, what do they want?
Weber, not Weber meter.
Weber, right? 1 Weber, right? Okay. Point P has a strength of has a magnetic field strength of 6 Webers per square megameter. Okay, so 6 times 10 to the 6th. We're going to use units to sort of guide our way through this thing. Yeah. Webers per megameter. Okay, so
square megameter.
Oh, square megameter. Right. It's
really critical.
Mega. How about we write it out? Megameter squared.
Yeah.
Where 1 megameter stands. What is the magnetic strength in Teslas?
Yeah.
This is in Teslas.
Okay. When you wrote it out, when I see it written out, I now see how to do it.
Yeah. Teslas is only in. Wait. Teslas are defined by meter squared. So in order to do Teslas, we have to make this a meter squared, which means we have to take the megameter thing here and square it. So we could. I'm sorry, my handwriting is horrible. So we could cross out the megameter squareds, and then we get Webers. What am I talking about? Webers per square meter, which is what this is defined as. So this is what you need to do. We're doing unit analysis. Crossing out the units, which means now we have to come up with this ratio. How many meters are in a megameter, or how many megameters are in a meter? They tell you 1 megameter is 10 to the 6th meters squared, which means you have to square this. So isn't the answer 6 times 10 to the 6th divided by 10 to the 12th, which is 6 times 10 to the minus 6th?
That was good.
Takes a second to figigure that out, right? Seth, unfortunately, did a very bad thing. When Seth looked at this, he told me, I don't know how to... Seth said, I don't know how to do this. Seth, you shouldn't say that, because then I thought of it as a hard problem, and that's why I stalled so much. This is a performance sport.
Okay, let's talk about other ways of doing it, and let's just address the subject.
Okay. No, wait. The psychology of doing problems is a massive part of a performance sport. We can't underestimate.
But it's not as massive as knowing what you're doing.
There's Seth talking. Okay, what do you think?
Okay. What you did was wrote the the magnetic the value. Okay, let me.
I should have put a question mark
Uh,
there. Cheating. Going
the
back.
value of interest is 6 times 10 to the 6. Uh, let's see. Webers per uh, megameter squared.
Right.
Okay. And we're interested in what is the value? Uh, what is the value in Webers per, not megameter squared, but meter squared?
Right.
So here's my thought. Now we replace a megameter.
Yep.
Is 10 to the 6th meter.
Right.
So we take this new expression for megameter and plug it into here.
Yep.
And so in the parenthesis, we have 10 to the 6th meter. So here is our value. This is what we're interested in. And the units are Webers per meter square, and the number of units is 6 times 10 to the 6th divided by is a square.
Seth caught his own mistake where I
yeah. You have to remember it's square.
Right. Yeah.
Divided by 10 to the 6th squared. And then doing the arithmetic. We get doing the arithmetic we get, 10 to the 6th divided by 2 10 to the 6th multiplied.
Right. Yeah.
Giving us 10 to the minus 6th.
Yep.
And so we get this.
Right. Yeah.
Okay.
Yeah.
So that is the approach that I was led to when you wrote down the quantity we're interested in reporting in different units.
Right.
With its units.
Right. Yep.
Okay. Now, a third approach is to think of the physics. So what this is talking about is you have this stuff, magnetic field, and it's going through surfaces. Okay, and the unit is how much stuff. A Tesla is how much stuff that goes through a square meter, right?
Right.
Well, if you have a certain amount of stuff, like 6 times 10 to the 6th units of magnetic field going through a square
megameter, which is a massive
amount
of space.
Enormous amount.
It's an enormous amount.
How much goes through 1 meter?
Yeah, a little bit.
Yeah. Well,
it's a lot less.
A lot less. How
much
less?
A lot less.
A lot less. Well, so imagine you have, the big square. The big square is 10 to the 6th 10 to the 6 meters square.
Yeah, massive amount.
It's enormous. And so how many little single square meters are there in there? They are 10 to the
Yeah,
12.
10 to the 12, right. So you have to divide by 10
So
to the
so you
12.
take this number, this big number, and divide it by the big number is 6 times 10 to the 6, which is 6 million, to get the quantity of Webers to a little square meter.
Yeah.
You know, a square meter is like, you know, like this much by this much.
Right.
You divide it by a million squared.
Right. Good.
Which is how much? That's a trillion.
Yeah. So,
yeah.
But you're multiplying a massive amount by,
Yeah.
So that's good. That's a very intuitive way of understanding it. That's great. Yeah. So right. Again, the best approach with these things is before the test to study how to do a whole slew of unit problems. I would think that the most seems to me like the approach of least resistance would be the way Seth did it here. This one is probably a great way of doing it. It works out really well when you have something per unit and you want to change to a smaller unit, then that's very, very easy. Okay, so that would be a situation where you want to have, 30 miles per hour, and you want to change to miles per minute. That's very easy because you would do 30 miles, and there are 60 minutes in an hour. Then you do 60 minutes, and it's very easy. It's just half a mile a minute, right? So then you lucked out of this problem because when you go from a big unit to a small unit, it's very, very easy to do what we just did because there are 60 minutes in an hour. So that works out really well when you have that situation. And that's a great way of doing it.
Let's I want to add one more thing.
Sure.
The principle behind the approach that Joel used. I think people need a reminder of that.
Oh, you mean my first approach?
The approach you used. I'd like to review the principle of it.
Go ahead. Yeah, it's a very powerful approach. It's called unit analysis.
But it's a very powerful approach, but I think for myself, I needed to review the principle of it. So
okay, go ahead.
Maybe, how about, could we erase like the bottom third?
Yeah. And by the way, in case people are interested, I don't think we're going to do any more than this one question today. I think we're going to unit analysis, these unit questions.
Okay, let's just do it.
Wait, do you want me to erase all this?
We're doing only one question today, so please, good. Now try to leave the tenses. Good enough. All right. Get rid of the red stuff. Good. Excellent. Okay. Here's the problem. So the quantity, I'm ready.
Go ahead, Seth. It's all yours.
The value is 6 times 10 to the 6 Webers per meter squared.
Right.
Okay, so here's the principle. One does not change the value when one multiplies it by 1.
Okay.
So the principle of changing units is to multiply the value by the number that is 1 in the units that give you the units you want.
Okay,
right?
You're starting to.
And so So this, what's in parentheses, is 1.
Right.
Now, so we need an expression for 1 that gives us the the units that we
Wait, you
want.
made a
Okay.
mistake. This thing is 10 megameters, by the way, Seth. It's not by
Okay.
meters, it's
Yeah.
by megameters. You
Oh,
made a
so we
mistake.
started out wrong. All right.
You started out.
So good. So let me fix it. In fact, yeah, yeah. So we're gonna go. We have. So in this problem, we're starting with the value. Okay, our value is Webers per mega. Uh,
We don't even know we don't even
yeah.
know
Okay.
the
No, no. Let
abbreviation
me
for
talk.
megameter.
Okay, we know what we know. We
Just
don't know
make it up. Just
is
make it up.
is Webers per mega meter
Squared.
squared.
Got it. Okay.
Okay.
Now continue.
Now here we go.
Yeah, go ahead.
1 megameter squared is equal to 10 to the 6. Oops. 10 to the 6th, also known as a million or mega. One million, 10 to the 6th meters squared. So the principle is that since 1 megameter equals 10 to the 6th meter, these two quantities with their units are equal. We could square both sides and then divide out one of the sides to get a 1. And we get this thing in parentheses, which has the significance of being this box here is equal to 1.
Right.
But its units are square megameters per square meter.
Yeah.
But the principle is you write a 1 by using the equations that relate the different units. You multiply the value you're given in the units you want to change. You multiply it by 1. You check that there is cancellation of units.
Yeah.
Which
I like that.
You check that there's the cancellation of the units, and you get and then you do the arithmetic. And then in this problem, you have to remember that what's in the denominator is 1 million meters squared.
Yeah.
So you have to remember to take 10 to the 6th squared in the denominator.
Right.
Before dividing it into 10 to the 6th.
Okay, so yeah, that was a really good justification for the cute little trick that I pulled with the unit analysis.
Yeah.
So I never really thought about that, but that's really justifying everything, which you got to do in math before you pull tricks. But notice for people who didn't quite see what's going on, let me make a little more explanation. You see how Seth wrote 1 megameters, 10 to the 6 meters, and he's talking about this one thing. Watch, if you write 1 megameter here and you replace it with 10 to the 6 meters, then you have, and then squared, of course, you have 10, look, you have 10 to the 6, I'll go into smaller typeface, it upsets Seth when I write too thick. When you have 10 to the 6 meters squared divided by 10 to the 6 meters squared, look, these cancel out and you get a 1. You see that? You see, that's why it's a 1. So that's okay, and that justifies you multiplying by 1, and then you replace 10 to the 6 meters with 1 megameter, and then the trick really comes in, and then all of a sudden it becomes useful to us, where we can cancel out these units and we get the answer. So good justification. You got to, at some point in math, no matter what class you're in, someone has to justify everything for you. And if the teacher hasn't justified it, someone else has. Don't worry.
Like yourself.
Yeah, the best thing to do is to justify stuff yourself, And that's what we get back to. The best approach to studying for the SAT is to try to understand every question as much as you can from all sorts of facets. And that's what we try to do here.
Yeah.
We try to help you see questions from different facets so that you really understand it. And then maybe you could do some fast ways of doing it.
Well, the really, really great thing about math compared to many other subjects is that everything that they teach you is something that you can, by your very self, justify and convince yourself of and discover the reason for. It's unlike subjects where the facts are from records of the past that you know of only because people tell you. In math, you could justify facts that either you think of yourself or the teacher tells you independently of the authority of the teacher.
Wow, that's pretty strong. So
that's pretty strong.
You know what I feel like doing? Why don't we we have an email address called satmathquestion@gmail.com. Tell you what, if your teacher's showing you something and you want a justification for it, email us, and then we'll feed it to Seth, say feed the Seth. And then Seth,
Joel could try it too.
I could also try it too. And then we could try to justify something that's going on in school. If you're seeing anything in school which is not justified to your standard, which is hopefully a pretty high standard, email us and we will try to justify it for you. Okay? And I think we're done for today. I think in unit analysis questions are not that easy. So I think we should do all 10. So this was question 11, and then we have 9 more to do over the next few months. Okay, so, by the way, wait, this is the best part. Well, not really the best part. That's an exaggeration. But why don't we see how they did? Okay, that's always nice to do. Let's see. First of all, did we get the same answer they got? Yes, we did. How did they do it? Oh, okay. Our job. It's so cute. It is our job to convert this to Weber's per square megameter. They didn't emphasize the word square, which they should have, because that's where you're going to make the mistake. Okay, so we need to solve for S. They make an equation out of it. The problem is that 1 Tesla is equal to this, so we can rewrite our equation as this. So they're doing it the same way Seth did it. This way, method 2, approach 2. They replaced megameters with 10 to the 6th meters. That's exactly how Seth did it. Yeah. And that was the way I suggested would be the way of least resistance. And then they got the answer. Yeah. So, wow, we all agree. This is the way of less resistance, and this is the way they did it. So, that's cool. Okay, great. Okay, so we're done. Okay, everyone, if you have any SAT math questions, please email us at satmathquestion@gmail.com. Please give us comments on our website or email us. And if you have any math things you want us to justify, please email them to us at our email address. Okay, everyone, have a good. That's a nice looking cup.
Okay, see you later.
Have a great day. Take care, everyone. Bye.